Hey, in this video we're going to learn something specific to only Java for now, which is ArrayList and LinkedList. We'll cover some differences, some similarities, so stay tuned. Basically, let's start from the ArrayList. Um, what is the ArrayList? ArrayList, we could say it's just a array in Python. It's almost same, like we just have different data types in Java. It has, so to initiate the array list, we can use like this array list, the integers as like the data type, and like this. We can also set like 10, which means it will be like 10 from the beginning, um, and some other parameters as well, which is like I would say more strict than in Python, because in Python we don't have such option. It's like in Python we just do whatever we want, integer plus string and plus list inside the list, but here it's we have to follow this rule, right? All right, so what are some, so let's say we initiated this one, the array list. Now how can I add something to the list, right? So the adding is easy. We just say array list dot add and our element, which is purely string. So let me do like this. It will be also purely it's integer, but now since it's a string, it's an error, right? So it doesn't get added. So simple. Also, well, same as the array list, we can have just like get, set, and remove. Basically, the basic functions. Also the size. Also the size function to show the size of the, and we also have the remove function to remove by index, okay, which is a little bit just getting familiar with the function basically. So the size, okay, the size says it's 5. All right, yeah, because we removed the fourth one here. All right, also let's do the dot contains and 4, okay. So we're asking, does it contain the 4? It will return true or false. So let's see. So it says yeah, true. Also, we have um the ensure capacity. Ensure capacity. Ensure capacity 10. Let's say. So okay. Oh, so I guess we just have to call it like this. To ensure the capacity. So let me run this again. Yeah, we're just ensuring that like we have certain standards, certain our uh, whatever requirements, right? So we're ensuring the array match what we want to do exactly. So currently we can see it's like the running process. It's being run. Yep. All right. Let's go this way. Yes. So let's try to run again. Okay. So the ensure capacity is to have, like, if you can see here, we can say it says minimum capacity and 10. So let me put 1 here. So let's see, because it's a void function, it should print itself something. Also, oh, it doesn't have to print anything. It's just how to say. Um, you remember, guys, when we said like here we put 10 for the minimum capacity? No, same thing, but we're just saying, hey, can you put it like as a different method? So you shouldn't confuse this, guys. You shouldn't. I know, like sometimes when you read the function, you think like, oh, this wording seems like this one, right? But actually, no. Actually, it might differ from what you actually want. So let's move on. Array, ArrayList, and let's check whether it's empty or not. So the ArrayList is not empty. Now let's check whether it's full or not. Let's check like this. Whether it's unempty, you know. So here we go. It's oh, I guess it's empty. True. Yeah, basically this means reversing the sign. So we're saying, yeah, it's not empty, so don't worry. Also, let's try is okay. I saw. Let's go. So let me try index of, and let me say like 3. So it should return 2. The index of 3 is 2. Right. So basically that's it. Now we could try. So we could try to remove here, and we also could try to iterate through it. So let me show you guys. Here we go. So ArrayList.iterator, the method passing it, and we're saying, yeah, it's an integer, by the way, because if I say, hey, I want string, it doesn't work, right? We have to follow the type once we're following from the beginning, you know. So yeah, so the looping is also like interesting. We can see here the has next. So we're going to the iterations like 0, then we see the has next. So after we're at the beginning, by the way, then we go to 0. So we're saying, hey, does it have any next? So yeah, we have 0. Then it says, hey, does it have any next? Yes, 1, right? So once we say it's next, we're going to come here, let's say 0, and say, hey, I'm taking 0 from this side. And we're just gonna take the value, return the value. That's it. That's how the iteration works. Super easy, right? Let me comment this real quick so we can move on to the next array. Yeah. All right, so let's move on with the linked list, which is not far different from our array list. All right, so same thing goes here. We just say, hey, linked list, string. What if we put list here? Could we put it? List, and if I say string, is it possible? Well, not really, right? Because the linked list, yeah, it inherits from the list. However, it has its own methods under the hood, which doesn't let, for example, this object add last work. So we always have to like the child classes to ensure that all methods will work. So it's basically easy. Just say, hey, add a. Basically it's the same methods that we were using. Um, let's see. add A, B, C, right? The same methods, the printing the object. Then we have the iterator again. So the has next same like working principle, and we can see here it's like removing um removing by the value rather than the index. So what we can think how it's different, how it's different from what we know already. So the linked list is, as you can see, it's linked to each other. So the thing is that with it, you can only iterate from the beginning to the end. That's it. There's no way to how to say get the specific index and return the value. There's no way. Like um, it's well, while in the array list it's like a random access. Here we have some strict access one by one, one by one. First in, last out, or oh wait, first in, first out, then till the last. The same thing happens. So that's it. And how do you think? Now, just think for a second. Just think. Is so since we can access, like, think of the array list as something disrupted, something that's just lying there. So if we add element to it, it's gonna be more time consuming, right? Right? Because we are sort of like adding something to the mess, while the linked list is it's just like one by one, one by one. So it's not really a mess, right? It's just we cannot find it later maybe, but it's for sure one by one. It's not doesn't use complex algorithms, and it's O log n. So O n, like the complexity is just n. It's because it's one by one, the operation. So you need to get fifth value. You need five operations. When like in the array list, it's sort of complicated. You just get five, get four, the fourth index, but we don't know what's happening under the algorithms, right? That's the thing. So it's faster, but so let's do the project. Uh, yeah, it's faster, but how can we prove that it's actually faster? Right? How can we like show it visually? So here we go, guys. I have this three slice of code here, slice of something, and let's do our project. Here we go. Oh, so I can put like this. I can put like this. So once it finish, so let me add five element, right? Let me comment this to make it fair. So printing everything, yeah, it's okay. So yeah, after this, print the time. Oh, also here add three, 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 C, B, C, D, E, right? Oh, wait, never mind. Yeah, like this E. Printing the object, I think it's not needed. Is it? Oh yeah, okay. So it's needed. Then I print the next elements of everything. So I have remove here. Let me remove the remove. Okay, I think now it's okay. Oh, I didn't put the time counter. So the time, let me put this like here. Um, this again, and this one here, the time, second time. So basically I'm just saying, hey, calculate the current time now, give me the current seconds. Then I say at the end of the program, hey, what's the seconds now? And I just say, hey, oh my god, so many seconds passed, you know. That's my strategy. That's to check the performance. All right, so, well, for some reason, let me do like 100 operations, I guess, 1000, and same code should go here, I guess. The integer, yes, this one. String should be the integer again. Yeah, so it's just our style. Okay, add array, let's say object. So I'm saying object add this element as an integer. So integer here, easy. Okay, now this one, let's see. Oh my god, I'm not supposed to print everything. Oh, right. D as next. Okay. Wait. Oh my god. Let's leave the. So let me do like this. So let's just leave only the printing time. Let's leave other things to itself. So like this. Print like this. You wanna print something? Just don't print. Okay. That's the philosophy right now. Right. So let's see. Let's see. Yeah, it's spilling, I guess. Oh my god. All right. So we are the code is having some troubles. That's weird because we just been showing it, right? All right. So what we can do? What we can do? So I think we can do our best is just in removing this iterators. Yeah, like this. Removing this whatever we have here. Yeah, leaving it like this exactly. Then here object add again. It's okay. So iterated 2, it's not needed again. Here first, the here. So let me put long time a here, long time 1, and here let me put long time 2, and time 1, time 2. Yeah. Let me save all of this stuff, and let me run again. All right, so it's still showing 1. So let's do like this. Okay. Because we can see the beauty only when it comes to the big operations, I guess. I guess my memory will not be overflow. I hope. Okay, yeah, it's being slow. Let me just do one more. Let's do it again. So it's still building again. So currently the process are building. The process are coming. Okay, it's parsing. Well, I mean the process are here, basically. The oh, it cannot show here. Okay. All right. All right. All right. All right. Oh, that's so beautiful. Yeah, so in this current example, the array list is somehow being faster. I guess it's just my bias of my computer. I'm pretty sure. I'm pretty sure. Look, I think if I replace these lines like this exactly, like this here, I guess I'm gonna get higher result for the linked list too. It's just it's just like compilers being like, oh, let me be fast. Oh, let me be slow. You know. Oh my God. Okay. Okay, so it's actually being fast, right? Okay. Well, then I guess my research on Google was wrong. But yeah, who does make the mistake? Or I don't know, some bias right now, like for CPUs or so for this IDE concretely. So I'll do the research investigation. Okay. Uh, how so the logically, how do you think when we will need this this types of things, right? When we will like what should be our like how to say the use cases, you know, when I should use this and that, you know. uh, well the answer is simple. If you want some flexibility rather than sticking element by element, element by element in the order, then just go with the linked list. But if you want some kind of wait, I mean, if you want flexibility, then go with the array list. A little bit flexibility in terms of the iteration, but not like not in the value. Well, I mean, yeah, like it's totally up to the persons, and we don't really limit each other. Um, Also, you can see that in this example, the the linked list is being fast, right? Oh wait, no, the array list. So let's say if you're doing some performance, then you may stick with the array list if it turned out faster on your computer too. So if your computer is running the array list fast, then yeah, just stick with it. Also, you have to be careful with the remembering the string thing. So let's do maybe we could let's do some little bit problem set. So I'll just have to like this because we don't need the time anymore. Let me just okay, whatever. Here we go. So let me create the not array list, but let's do like array list, but alphabet, you know. And let me put like the char character. Yeah, character. Yeah. So you know the alphabet like A B C D. So let me just do like alphabet dot add and A dot add B dot add C. So this is our alphabet now, and let's try to print it. Println and alphabet. Yeah. So let's make it building. Let's make it build. Yeah, ABC. So we have to use this quotation for the alphabet. And well, think of your any use case basically. Like how could you utilize the properties of the array list? Let's say we say let's say we have like confusion, between the languages. So we just say, hey, is this Chinese characters, for example, something like this in the alphabet, but we know it's, but the program says, hey, no, it's not. Oh, well, let's like this system dot alphabet that contains, and let's say like this. Let's say somebody or the robot doesn't know, is it a letter or is it like symbol? So we could use the false, right? Okay. Um, why do you think we need this is empty something kind of things? Well, easy, right? We need this to delete the elements, right? We need the, like, if we don't have anything, we cannot iterate or we cannot really delete something from it. So we will get some errors. That's for like debugging, to prevent the error debugging, to prevent the error occurring. So like we could say, um, let's say I don't know what's the index of, let's say A. Oh, let me try this one. I guess it will be error. Oh, -1. Yeah, because it didn't find anything. So this one will be the 0, right? Because it's the first one. So we could say, hey, I remember the alphabet, but I don't remember the order. So can you tell me what is A? So we just say like this, right? It's fine. So for example, ArrayList here implements the list interface, but the linked list is like list queue and dequeue. It's far more complicated. Um, and each array list here contains only itself. Hey, like, hey, this is only me. Like, A, hey, this is B, this is C, But for the linked list, the thing is like, it contains itself three elements, like data of it, like A, B, C. Oh wait, I mean the A, like A, and contains the data of like the reference sort of to the previous data. But here we don't have. But let's say B, it contains reference to A and C, right? It's sort of like linking itself. And for example, like uh, like it all depends on like really us. How to say, it's not, there's nothing like we could do. So we could try to um, what we could try is we could try the methods of such like converting, casting, not casting from the element to element, but rather like casting from the, like, let's see, I have ready code already, so yeah. So erase array. Okay, let me import the arrays. And insert arguments. Yeah. So string. Let me call it. Right. So, for example, this one is like not creating like this and adding, but rather the type when we say, hey, we have this array one. Can you create me the ready one? Like from the beginning, you know, it's like template. Also, let's try this one. Yeah, same, okay? But what's the catch on this? Well, the catch is that it's immutable. So let's say add, and let's say 2 again. Let me add 20 in the, not as an integer but string. Yeah, oh, so it's adding. Okay, that's weird because yeah, a little bit confused. Okay, that's fine. Um, how about like if we used some strings, if we used to convert to string. So let's say I do like this, then I say, hey, convert me to string. Let's see. Yeah, it still works, so I guess no problem with that. So guys, that's it. The tour with the array list and linked list with the problem set was like the the sugar differences is finished. So if you're interested more, you can um, dive into the documentation or ask any questions in the comments. I'll be happy to answer them. So see ya.